Welcome to the Flexible Commercial Building session of the National Energy Efficiency Council's conference. So I hope you're ready for an action-packed session that will take us across the world of flexible buildings, both figuratively and literally. First, and most importantly, I would like to acknowledge the Boon Wurrung, the traditional custodians of this land, Bayside, Melbourne, that are joining from, and pay my respect to the elders, both past and present. So you're joining this session because you're interested in the flexibility that commercial buildings could pose for our energy system. And we wonder why that's such an important thing. It's the sheer volume and the prospective impact that they could have. Commercial buildings account for roughly 10% of Australia's carbon footprint, and the Energy Efficiency Council is very passionate about ensuring those buildings make our lives healthier and happier as we transition towards a net zero world. While there's plenty to be done in improving energy efficiency of our building stock, as many Melburnians who lasted through a winter lockdown will attest to, many are turning their minds to how we wake up the latent capacity that we all work in. Increasingly, these buildings have solar, many have HVAC and heating, hot water, and all of these things pose an opportunity for flexible demand. Increasingly in Australia, we are benefiting from large-scale, low-cost, clean, renewable energy. However, that requires flexible demand to meet it at different points in time. So today, we're going to meet that challenge and figure out how we're going to unlock all of that. And thanks to the spectacular Energy Efficiency Council team, we have 3 experts to run us through the steps. We're going to start at a global level with Søren Østergaard Jensen all the way from Denmark, then zoom down to a national level with Stephen White from CSIRO, and last but not least, we'll hear from Janaki Dhagat from Charter Hall, who will give us the lived experience of limbering up a building fleet. Once we've heard from our marvellous speakers, we'll take a short break before coming back for a chat based on your questions that you put in the chat during the session. So without further ado, let me introduce our first speaker. So Søren is the operating agent, Annex 82, for energy flexible buildings towards resilient low carbon energy systems at the International Energy Agency. Søren has nearly 4 decades of experience in the field of energy performance of buildings, including solar energy. Currently, his research is divided between low energy and energy neutral buildings, thinking about how buildings can stabilise the future energy systems with a large amount of renewable energy sources, something here in Australia we are really going to need to think about. So, Søren, I'll hand over to you. Thank you so much.
Thank you very much, Liz, and thank you for the opportunity to talk about the work we have done in IAA EPC about energy flexible buildings. Next, please. I've been asked to talk a little bit about the International Energy Agency. It was formed at the oil crisis in 1973. It has currently 30 member countries and 8 associated countries. And the mission is to work with government and industry to make a more secure and sustainable energy future. And among other things, I have some affiliated groups called TCPs, which stands for Technological Collaboration Platforms. We have 40 of those. There is a link at the bottom of the screen. You can look more into this. Next, please. So the area of work in IAA is promote energy efficiency, ensure energy security, international collaboration, data and statistic training, technology collaboration, and global engagement. So EPC is actually under technology collaboration. Next, please. So this is very complicated, but if you follow the blue color, you end down to the bright orange, where we have EPC, which EPC stands for Energy in Buildings and Communities, where these 2 annexes I are going to speak about are situated. Next, please. So the mission of EPC is to transform the built environment towards more energy efficient and sustainable buildings and communities. And we do that by development and dissemination of new technologies. And we have a strategic plan, as you can see to the left, and a link to this plan at the bottom. Next, please. So at the moment, the 5 areas of interest for EPC is integrated planning and building design, building energy systems, building envelope, community scale methods, real building energy use. Next, please. So here is 3 links. The first one is for the annual reports, where you could read what we have done over the different years. We have 68 completed annexes, and we have 18 ongoing annexes. So we are actually on 86 now, and making EPC, I think the TCP with most work going on. Next, please. So why join an annex? An annex is very different from normal projects because there's really no money in the system. Each have to come with their own funding from home, and you can join an annex if you're interested in the area. You have money with you from home, and your country is part of EPC. And why join such an annex? Well, it broaden your horizon and create better solutions, because you often get to work with people you never knew before and maybe never else would have known. And that you also obtain a great large network, and that's really important for young researchers like PhD. And then it's great fun. On the other hand, for me as an operating agent for an annex, it's quite difficult because I never know who will come into the annex and what will be the outcome of it. But still, it's great fun. Next. So I was operating agent. It's a leader of Annex 67 about energy flexible buildings, and you can see there a link to what we have achieved. And we are now starting up a new annex because, well, we nearly scratched the surface, and there is a link where our results will come in the future. Next, please. I think if we disregard Trump, everybody have a common understanding that we need to replace fossil fuels with renewable energy, but many of these energy forms are quite fluctuating. They are not always there when we need them. That goes for solar, wind, and wave, and so on. Hydro is more controllable. Of course, biomass we can store, but biomass can be used for many other very important things. So we should not use that too much. Next. So an example on why we need flexibility is from Denmark, because, well, I know that I'm Dane. So by now we should have 50% wind in the grid, in the power grid, and we should have only renewable sources in the total system in 2050. Next, please. And here is a graph showing the wind in the power system. It's only going to 2015. So here we are nearly 50%, but now we are about 50%. And that's, well, we accomplish what we want, but it also gives some problems. Next, please. Here you can see the red line is the demand for power in Denmark, in part of Denmark for 3 weeks in the winter, and while the gray area are the wind production. So you can see there's not a complete match, on the contrary. Next. So here we have excess production, so who will consume more or store energy? Next. And here we have too little wind energy, so who will deliver some energy or who can consume less? And this two blue circles show that we need some kind of flexibility. Normally we had large fossil fuel power plants to create the stability, but they are being phased out. So we need to have something else to make the production and the consumption match. And here we need flexibility, and that can be obtained on very different scales. We can have interconnectors between countries. We can have large battery storage. We can have power to fuel factories and so on. But here in this annexes, we are dealing with buildings. So next. Buildings have, of course, an energy demand, but actually it's not. It seems stable or it seems fixed, but we can actually play with it, so we can use more energy at some points and less energy at other points in order to better match the energy production. Next, please. So in commercial buildings, next, we have a ventilation system we can regulate up and down. We have next. We have cooling systems we can regulate up and down, where we could have a cold storage where we cool down a water storage during periods with a lot of energy, and then shut down the cooling plant during periods with less energy. Next. We have pumps. Well, pump doesn't really use a lot of energy, but actually I've heard on the worldwide is about 10% of the power used for pump. Next. And if we look at supermarkets, for instance, we have all these display cages where we have goods stores in cold environments, and actually these goods can be used as a kind of cold storage, but of course we cannot jeopardize the temperature, because then we lose the food, and that's worse than having less flexibility. So we really have to be aware of that. Next, please. Annex electricity demand in household. Next, please. Here we have heat pumps or air conditioning, where we can have some kind of storage in, for instance, water, but the construction of the building themselves are quite good storage and can have a lot of heat or cold stored in them. Next, please. We have the EVs with batteries. We can charge and recharge in order to get a better match between consumption and production. Next, please. We have a ventilation system. Well, they are quite small, but still it can help stabilize the grids. Next, please. And of course, white goods, we can control them in order not only to run when it's most suitable. Next, please. Well, an example, this is a small feeder, a Danish feeder, where we have a very distinct peak between 7-hour and 19-hour. That's what we call the cooking peak, where people come home from work and start cooking and start television and light and so on. And the green line, vertical line, is what can this feeder actually accommodate. So this is okay for now, but what is when we start to use more electricity for heat and so on. Next, please. Here we have a situation where all these houses have heat pumps, and 40% of the homes have an EV, and you can see we go about max allowed load. So what? Oh, one back. So what do we do? The normal way is to enhance the grid capacity. So we increase the vertical green bar. Another way is to be more clever and use flexibility. Next, please. So here we have a situation where we are using the flexibility. Next, please. Before the cooking peak, we preheat the houses so they are a little bit warmer than normal, but still within the comfort range. Next, please. So that we, during the cooking peak, can have more or less free floating of the houses that don't need energy input to keep the temperature. Next, please. But of course, afterwards, we have a rebound period where we need extra energy to restore the situation in the houses. Next, please. And then we can intelligently charge the EVs in order not to go about the limit, because, well, often you just plug in your EV when you come home, but if you just need the car 10 hours later, it's not that important you charge it right away. So in this way, we can, by using flexibility, next please, we can actually manage a situation that normally would have needed for more copper. So next please. And this is a new situation that has emerged during the last decade. Prosumers, that's consumers that not only consume but also produce. Here, 2 buildings with a large PV surface on the roofs. Next, please. And here we have a small feeder. Next, please. So that is the normal situation without PV or with PV, but during the night, the voltage level is decreased going out the feeder. Next, please. But if we have PV, the voltage level might increase going out the feeder and even go above the max allowed voltage level. Next, please. So we have to curtail some of the energy we could have produced, so that is wasted. Next, please. One way of doing it is, of course, to lower the voltage level at the transformer level, but in Denmark at these low-level feeders, the transformers are manual, so you cannot have a man going out several times a day to adjust it. So either you need to go automatically, and that's quite expensive to upgrade the transformer, or we use flexibility. Next, please. Where some of the excess energy is stored in the buildings, either in batteries or as heat or cold in the construction and so on, in order that we don't need actually to enhance the feeder. Next, please. In Annex 67, we come up with this definition of energy flexibility, which we hope are quite easy understandable. The energy flexibility of a building is the ability to manage its demand and generation according to local climate conditions, user needs, this is very important, and grid requirements. Energy flexibility of building will thus allow for demand-side management or load control, and thereby demand response based on the requirements of the surrounding grids. Next, please. So what is the possible energy flexibility in buildings actually? Well, the really quick but precise answer to this is, next please, it depends. Next please. It depends on the type of building and the energy service system, how you use the building, the climate, the time of the day and time of the year, how is the occupant, do they want to participate? Can we control the energy service systems? What is the state of the storage? If we have a full storage, we cannot put more into it, or if we have an empty storage, we cannot discharge more. The physical max of energy flexibility is normally much higher than the cost optimal level of energy flexibility. Sorry. And then the surrounding grids is, of course, important. If the surrounding grids don't need the energy flexibility, it doesn't really matter how energy flexible a building is. And of course, then there is the energy tariff. What is it in for me? Can I earn some money in participating in this scheme? Well, so it's not that easy. Next, please. So we have come up with a way of characterizing energy flexibility. And here we are using a flexibility function. That's the black curve. And this is a very simple way of showing what is a flexibility function. You have a control signal that can be a penalty signal or reward signal, disturbance signal. Here is the energy price. So we have a step, that's the red curve, where suddenly the energy price is increased. So what will a responsive building do after? I don't have a cursor, so I hope you know the Greek letters. After tau, the buildings will start to respond to the increased price. After alpha time alpha, we reach the max flexibility delta. after which some of the devices need energy again. And after time beta, we have no more flexibility. And then we go into a period of rebound where we try to restore the situation as it was before. So capital A is the area where how much we actually shift, and B is actually the cost of shifting this amount of energy. Next, please. So, well, based on this, we can estimate some indexes. First, the expected flexibility saving index, which is more or less seen from the customer side. What can I save? So, next, please. Here we have 3 buildings. Building 3, the blue one, is a very fast responding building, but that cannot stay flexible for a very long time. Building 1 is, for instance, a low energy building with a lot of thermal mass. It's not that quick responding, but it can lower its energy demand for a very long period. Number 2, red curve, is something in between. Next, please. So here we have 3 grids, wind, solar, or ramp grid, where the wind and solar is actually based on Danish data, while the ramp is on Norwegian data. So you can see wind. There are often several days wet wind and then several days without much wind, while solar it's by daily. You have much or little solar, while ramp penalty is normally when you have in the morning you have a shower, or in the evening you have a shower, and that's here is for Norwegian, so it's a power grid, but it could just also be a district heating grid. Next, please. What this says, how much can you save? So building 1, the slow responding is of course best for wind that has this very slow fluctuation, while building 1, the fast responding building, is best for the ramp situation, and building 2 is best for solar because it's more in harmony with a daily swing. Next, please. We can also calculate the flexibility index, and that's more seen from the utility side. Next, please. And here the penalty signals are more, it's more generic. It's just on-off because it's more easy to handle by the utility. Next, please. And then we can calculate the flexibility index, which actually say how much of the time are these buildings actually can they help the grid. And here you can see, well, for the ramp situation, building 3 can more or less help all the time, while building 1 in the wind situation can help 1/3 of the time. Next, please. And here you have the 2 indexes, and what you can see is if a building is good for wind from the consumer side, it's also good for the utility side, and the ramp side. For instance, building 3 is good both for the utility side and the consumer side. So that's really encouraging. So if a building is good for the utility, it seems that it will also be good for the consumer. So both parts can earn something on this. And there's a link to a paper at the bottom where you can read more about this. Next, please. So here is a building where it's a bit more sophisticated. If you take the top graph, red curve is a conventional controller just trying to minimize the energy demand while staying within the comfort boundaries, which is the dashed line. A flexibility controller is the green one. You can see it's not that easy to understand why is the temperature not just following the lowest possible case. Well, you can see that in the middle graph where you also have green and red. And you can see red, it just use energy whenever it's needed. And the black bar is the penalty signal, which is here the CO2 contents in the energy, while for the green curve, you can see the green curve mainly try to use energy when there's a low content of CO2 in the energy grid. The bottom graph, you see accumulated CO2, and you can see that the flexible controller can lead to about 20% less CO2 footprint than the conventional controller. Next, please. Which can be used for labeling of energy flexibility. Next, please. And again, here's a link where you can read more about this. Next, please. The former slides showed a building with a forecast. In order to utilize or create a very good controller, you need some kind of forecast. Can you go one back? Yeah, here you can see that if you see the top graph, that the green controller actually start to use energy during the night where there is not really a need for it. But as you can see, it is in the second graph, it is during a situation with really low CO2 in the grid, so that we actually store energy in the house, so that we are not we do not need so much energy during periods with high CO2 content. Next, please. However, we cannot just put as much energy into the house as we like. Well, we can, but it doesn't really give more. Up to a certain point, it will not give more flexibility, as you can see in the curves going down. At a certain point, we have a saturation, and then we can not gain more flexibility by preheating the building. Next, please. So Annex 67 is finalized, and here you see a homepage of Annex 67, and you have the link there. Next, please. And if you click on publications, you will see you can get links to papers and articles. And we have made a position paper. We have made some reports and a couple of softwares, and mainly the deliverables, which is actually what is approved by the ESCO of EBC. Next, please. So this is the deliverable of Annex 67. So we have an overall report summarizing the main findings of Annex 67. We have a report dedicated to the characterization of energy flexibility in buildings. We have made some studies on the stakeholders' point of view on energy flexibilities. Several control strategies and algorithms for obtaining energy flexibility in buildings have been reviewed and evaluated and described in a report. We have used some facilities for testing flexibility, hardware in the loop facilities, and report describes these facilities and what they have obtained. And then we have a very big report with a lot of different examples on how to obtain energy flexibility in buildings, which maybe could inspire you in your work. And lastly, we have a very small brief summary of the outcome of Annex 67. Next, please. So we had 15 countries participating in 67. Next, please. But, well, it's only the start. So we wanted to dig deeper into this flexibility. And we are just starting. Next, please. So in Annex 67, we mainly study single buildings, a little bit clusters, but now we'll go into clusters and communities where an important word is aggregation, because many buildings only can deliver a little bit flexibility, but accumulated is quite much. but we need an aggregator to collect this and bid that into the market. We also will study flexibility where we have multi-carrier. So in Denmark, many buildings have both electricity and district heating. So here we, of course, also need aggregation, but we also need a way to prioritize between the different energy sources, when to use what in order to gain as much flexibility as possible. We did a bit on stakeholders, but here we like to dig in even deeper and also look at not only how to make the stakeholder accept using flexibility, but also make them a tool, involve them so they can be an active part of energy flexibility. And what we didn't do in Annex 67 was business model. So we will also have a subtask on investigation of a business model, because if there's nothing in it for me, I might not like to participate. So that's very, very important. Next, please. So we have had a preparation phase. We hope that we will be allowed to start the working phase by January. We have one problem that my funding is not yet secured, but we hope by December it will be. And then we will have a 3-year working phase and a 1-year reporting phase. So if you're interested, you can join. Next, please. So even more are now interested in joining the Annex. We have 21 interested countries, and it seems that Australia maybe also will be interested. So let's see. Next, please. So if you're interested in Annex 82, so then please contact me, and I can give you the Annex text and the preliminary work plan and guide you to who you should talk in order to get involved in different subtasks. Next, please. This is an old drawing, but it's just to say that yes, Annex 67 and 82 is about buildings, but there's a lot of other IA TCPs dealing with things that are actually important to understand in order to make energy buildings energy flexible. Next, please. Yeah, thank you for your attention.
Thanks so much, Søren. Really appreciate that. That was fantastic. And so with that amazing view of how we can calculate and look at the energy flexibility in our commercial buildings, we're able to move to Dr. Stephen White, who leads CSIRO's energy efficiency research, which includes buildings to grid data clearinghouse, as well as iHub. Stephen's going to run us through some of the details around iHub today and really start talking to us about the role the data is going to play in unlocking the energy flexibility in these buildings. Without further ado, go for it, Stephen.
Cool. Thanks very much, Liz. Yes, so I was asked to talk about the Air Conditioning Demand Response Atlas, which is a resource assessment of just how much demand response we could actually get out of air conditioning around Australia. I've also snuck in some work on the data clearinghouse and how that sort of helps to address the issues. Next slide. So I guess we come at it from that sort of question of, well, you know, if we've got this need for flexible demand in the grid, where should we get it from? Should we get it from batteries? Should we get it from plugging in our electric vehicles and charging and discharging in some coordinated way? But from the perspective of iHub, led by the Australian Institute of Refrigeration, Air Conditioning and Heating, we're interested in what demand flexibility air conditioning can provide. And at least in theory, the hardware for this should come essentially free. That is, we have the air conditioning already installed, and in large part we have building management systems and the control capability to tweak demand. But unfortunately, I would sort of posit that it's kind of the industry alignment and the transaction cost of actually achieving that demand response, which is the issue. So, you know, how would you go about breaking that apart? And I think the opportunity lies in digitalization. I mean, we have different terminologies for that in different countries. I think Europe likes digitalization. Smart buildings may be something that you're more familiar with as a term. But unfortunately, in work we did with ERA, with over 150 engineers around the table, the general consensus was that our building control systems are in the mainframe age of computing and have not yet advanced to the app age. So there's something about the way we do the interface between the electricity system and the buildings which needs to be addressed. Next slide. You've got to ask yourself, is this a material opportunity? I think perhaps Søren's presentation has at least partly looked at that, but from an Australian perspective at least, just looking at the regional energy consumption as a function of ambient temperature just shows how much this temperature-dependent load is the cause of peak demand. So, for example, in South Australia, in the low 20 degrees Celsius ambient day, you around about 1.5 gigawatts of demand on the electricity system, and that climbs up to around 3 gigawatts at temperatures above 40 degrees Celsius. You know, that's a doubling of the amount of demand. So clearly, air conditioning, which is the major load that's causing that, is very, very material. Next slide. So we took this from a top-down analysis. There are a number of papers and analyses that have sort of tried to build it up on a building-by-building kind of a basis, but we came at it from a top-down perspective. So we took the consumption data at each substation from the distribution network service provider, processed that, which is a non-trivial task, and then federated that data with the weather data in order to work out what that baseline load is. That's that amount of load that's at a neutral ambient temperature, and separating that out from the temperature-dependent load. We took just the cooling load component of that because we were particularly interested in the peak summer demand. And then we harmonized that data set with the Nexus database, which had the amount of commercial buildings and residential buildings around Australia by postcode. And so we were able to then split that cooling load into what is in residential loads and what is in commercial loads. And then the final step of our analysis was to work out how much demand response potential there is as a fraction of that cooling load. Now, the key point here is that the demand response that we were looking at was from nudging of thermostat set points, nudging by around 2 degrees Celsius. This is not switching off air conditioning. This is still supplying air conditioning, but supplying it, but allowing the thermostat set point to drift. So this is not sort of the big red button being thrown at buildings. This is allowing a little bit of drift and keeping essentially within ASHRAE comfort guidelines. Next step. We validated that model for a particular data set that we had, which was of 70 homes in southeast Queensland, comparing the aggregated load of all of those 70 homes and disaggregating that into the air conditioning load as per the previous slide, and comparing that with real monitored air conditioning load. The right-hand little squiggly graph that you can't read there is just showing that it seemed to follow the actual measured data very well. And when you then took the averages by hour of the day and averages by the apparent ambient temperature, it is clear that our model seems to follow the load on the basis of temperature quite well, but there is a little bit of offset in terms of the time of day that our model predicts. And I think probably the most significant confounding factor that, that is causing that bit of offset is possible correlation between solar PV load, which is embedded inside the actual net load on a network, which is probably has some cross correlation with air conditioning load. So we felt pretty comfortable that we had a good model that was quite valid, and then we broke it down by substation around Australia. So next slide. So right at the macro level, looking across the entire NEM, here you can see what the load on the NEM is at the 99.5 percentile case. So the baseline is the black curve there by hour of day. And you can see the box and whisker plot there is all the data points across the year. And the dotted blue line is what the load would be on the NEM if we were able to achieve that 2 degrees Celsius temperature set point adjustment. And that would be equivalent to about 1.2 gigawatts of peak demand reduction. So that's peak demand reduction coincident with the peak on the system. That's almost 6% of the entire NEM as flexible load, which is available just from nudging thermostats by 2 degrees Celsius. I mean, in an extreme sort of grid security kind of thing, you could look at actual curtailment of the air conditioning loads totally, and then you would increase that by a factor of 3 to 6. So that might be more in the order of 5 to 6 gigawatts of capacity in the system. Next slide. And so because we built it up from network substation data, we're able to map that against postcodes around Australia, and we can do heat maps of where all that demand response capability is from air conditioning. Interestingly enough, the demand response potential of commercial buildings on a given substation was in the order of 1 to 4% of the peak demand on that that network, and for residential load, there more in the order of 5 to 15% demand response capability. So residential seems to actually hold a bit more than commercial, but presumably commercial should be relatively economic because you get a larger chunk for every given building that you go into. Next slide. And so you can actually drill down into the data. We've posted the HVAC demand response atlas on the web there in a Tableau database, and you can see that you've got lots and lots of different bells that you can twig to sort of drill down into that. We've broken it down into bins by month, by time of day, and by ambient temperature. And in each of those bins, you can get the median value for the demand response potential in that substation, the percentage of peak demand on that substation, the half-hour value of on the wholesale electricity market, and what the total air conditioning demand is there. And you can look at it from either a commercial buildings perspective or a residential buildings perspective. Next slide. And so you've kind of got the graphics that come up. You can hover the mouse over the top and you can look into a given distribution network service provider. So for example, there I've got the mouse hovering over SA Power Networks. And what you can see that in February, between midday and 4 p.m. And when the temperature is between 34 and 40 degrees Celsius, the median demand on SA Power Networks is around 1.6 gigawatts, of which 388 megawatts is commercial air conditioning, and of that, around 69 megawatts would be available as demand response potential from a 2 degrees Celsius nudge. And there's a half-hour wholesale value number there as well. Next slide. And you can break down into individual substation. In this particular case, the Findon 11 kV substation there, same bin there. But the interesting thing, the reason I hovered over that, was that as much as 10% of that particular substation was available as demand response from commercial buildings. Next slide. And so I guess there's a lot of potential there. And so why aren't we talking more about this? And I saw a presentation just recently from the American Council for Energy Efficient Economy, ACEEE, that probably most of you are quite aware of. And they actually named 3 particular barriers that are crucial here. One is interoperability, that is the control systems and the software being able to talk to each other. So instead of language on that particular one, you could put your control system vendor name. Can they talk to each other? Cybersecurity is clearly a crucial issue there. And it's not that we don't want to achieve cybersecurity, we definitely do. It's just how many times you have to do it for every given service that goes into a building. And so if you've got to go into a dedicated discussion with the IT people in your building just for obtaining, 100 kilowatts of demand response, that's going to be a big transaction cost to overcome the cybersecurity issues. There's a lot of workforce barriers, there's skills barriers, and there's also supply chain issues there that are probably too detailed to go into at this point. Next slide. So our sort of way of looking at it, this is in the Affordable Heating and Cooling Innovation Hub. Our way of looking at this is that data is in fact kind of the glue that sort of enables demand response providers to be able to engage with the building owners, because you can't manage what you don't measure. And so until you've got that transparency of data flowing, there is no game to be played. And so what we've been doing in the Affordable Heating and Cooling Innovation Hub is creating what we call the Data Clearinghouse, which is a multi-user data consolidation platform that can host what we call applications on it to enable things like demand response. The key thing is it's not just demand response. Ultimately, you want to take the data out of the building once, get it through into the cloud, and then be able to transact many different services off it. So at the moment in the project, which is supported by ARENA, we've got more than 25 buildings pledged to be on the Data Clearinghouse, and we are trialling a number of applications with a particular focus on demand response. Next slide. And so just as another way of putting this sort of thinking about this, we kind of almost consider the data as being the poles and wires of actually getting a whole range of different services there. And so that task of getting the data out of the building, federating it with other data sources, making it interoperable and presenting it through APIs in structured formats is a good chunk of the barrier that is being overcome. And then the analytics providers, the demand response providers, etc., they can transact off a common source of truth. Next slide. And I think I kind of half mentioned this before. The key point here is that if you're coming in as the energy industry and you want the property industry to bend over backwards for you to provide you with this demand response, you're probably going to have a hard time. It actually has to be part of a more holistic view of building services. And this slide here, I mean, you won't be able to read all the detail, but it's just showing all the different services that are being provided in the building that are all built off the fact that you've got to be able to get data out of the building to be able to offer a service. Next slide. So just going back, I guess, to conclude, we posited that air conditioning was the low hardware cost solution, and we need to overcome the barriers around industry alignment and transaction cost. And we believe that the way to do that is through digitalisation enabled through smart building technology. Thank you very much. Just want to acknowledge that ARENA has supported this work, so we're very grateful for that. Thank you.
Thank you so much, Stephen. That was fantastic. So interesting to see that actual figure of 60% in the NEM. And I think quantifying that is a lot of value, especially now that we're going to start to hear from Janaki Dhagat, who heads up the sustainability at Charter Hall, but he's also the chair of the Better Building Partnership, and he's going to run us through some of the practical on the ground scenarios of how we get more flexibility in our commercial buildings. Thank you.
Thank you, Liz. Thanks, Liz. As I said, I'm here today in my capacity as the chair of the Better Building Partnership, which includes a network of 13 property owners representing about 59% of the Sydney's CBD commercial office space. Next slide, please. The purpose of the network is to drive a collaborative approach towards integrating sustainability in the property industry. And it basically drives change through transforming markets, benchmarking progress, embedding sustainability at scale, and engaging with the industry and government. Next slide, please. In recognizing the important role that commercial property have to play in ensuring the reliability and resilience of the grid, one of the projects we commissioned in 2020 was to develop a demand management planner and case study to really help the commercial property owners to understand and actively participate in the electricity market as it transforms to a renewable electricity system. So in my presentation today, I will talk through what motivated the project and some of the key findings. Next slide, please. So to begin with, why did we commission this project? It was really, to demystify the value of demand response for commercial property. Operating costs for a building is serious business. With the volatile energy market behind one of the greatest or largest manageable operating costs of a building, there's a laser-like focus on managing electricity cost. However, when it comes to engaging with the grid, there is a web of complexities that is really hard to navigate through. So the aim of the project was to demystify the value of the demand response in commercial property, not only to realize the commercial benefit, but also the impact on the resilience of the grid. Secondly, many of us are setting or have already set our net zero carbon targets. And in charting our pathway towards net zero, efficient buildings running on renewable energy is the mantra. And the transition to renewables comes with the understanding that renewable electricity has a different performance characteristics to fossil fuels, and that managing demand is one of the important strategies to balancing the electricity system. Given that most of our assets are CBD towers, the opportunity for on-site solar is limited, so most of the renewable electricity needs to be delivered by the grid. In creating demand for renewables through procurement, we need to be playing a more active role in balancing supply and demand through the grid. And finally, as we look at the future of smart buildings, we know that buildings need to be ready for the transformation towards electrification, EVs, electrical vehicles, as well as thermal storage and batteries. And in order to make the most of this transformation, we need to understand how best to work with the grid. So it was a combination of all of this that really motivated the commissioning of this project. Next slide, please. So I'm going to run through some of the key findings that we uncovered through this project. First and foremost, I think, was that energy efficiency is still front and center when it comes to contributing to year-long demand management of the building. We commissioned 3 case studies as part of this project, and all 3 case studies maintains that. And that is something that we do look at quite proactively when we look at managing our buildings as efficiently as possible. The second was that price signals are difficult to understand by end users like ourselves. Now, there are price signals in the market, and while it's expected that this will drive demand response, as an end user, the price signals, there are multiple price signals. There's generation side price, there's transmission side, there's distribution price. So which one do we respond to? When do we respond to it, and how? And these are all really challenging pieces of the puzzle that we need to work out so that we can benefit from it. So despite there being price signals, if we can't interpret the price, we can't take any action. So in reality, we are not really, in the current stance, we are not really active participants in driving supply and demand when it comes to the grid. The other aspect of the price as well is then to quantify or measure the savings that would drive more action. So again, throughout the 3 case studies that we looked at, in trying to understand how the tariff would incentivize us to manage our demand better, it was just looking at one particular tariff was like a 3 days work. So when you've already got a day job to do, this isn't something that, you know, is a practical way to actually realize and you know, operate in a BAU situation. So this is a real challenge, and if you can't quantify savings, it's usually hard to get these projects or participate actively in this. And then data, we've now got more data than we've ever had before in terms of building information, but information barriers still exist. And I think this is where the market needs to move a bit closer to close this information gap. We have data tools like metering, sub-metering, etc., but we now need to see this through in the continuum towards turning that data into information, and then through to knowledge, and then actually applying that. And then the other aspect in terms of challenge is the significant amount of stakeholders that would need to be engaged in any kind of demand response measure. So as an example, the number of stakeholders that needed to be engaged in one of the case studies just to turn a generator on was staggering, and that is a real barrier. So in terms of explaining the concepts to the different stakeholders, managing the risks and you know, mitigating risks associated with that, and then, you know, actually working through the process of you know, the measure. Thermal inertia was something that I think Steve spoke about earlier, and while, you know, this is a real opportunity, we have better information systems in the building to understand this, but it hasn't really kind of seeped through in terms of, you know, how do we communicate this with our tenant customers in the end. And this kind of brings me to the next point, which is around the the tenant engagement piece. So the purpose of a building is to provide a productive place for the occupants to work in, and thermal comfort has a critical role in this. So set bands, that's, you know, in most leases is usually, you know, a real challenge to move plus or minus around. But having said that, different environments could provide different degrees of compromise. You know, for instance, a university building where you have different rotating users as opposed to a static office building where you have, you know, lawyers. So, you know, you can kind of work with the type of occupants you've got in the building that you're working with to be able to manage thermal set points. And then we also found that overall, even though, as I said, there is more information out there, there is still the degree of opportunity and the benefits from demand response remains really low. Anyone that's going to be an active participant in this space needs to be able to join the dots through meter data, through tariffs, and just understanding the energy grid and everything that comes with it. And that continues to be a challenge for most people. So how do we make information that's so easily available that you don't really need to think about it and actually just, it becomes seamless? And that's challenging, but also the opportunity for demand response to really work. And finally, there is a need for the market to support this delivery. And as we move towards carbon neutrality and our net zero targets, I think demand response is going to become an intrinsic part of that over the next 5-10 years. So we in the property industry are really keen to understand demand response, and that's what drove the study. And we've identified a number of challenges through this project, but also the opportunity for the market to come up with a solution. And we've developed a planner to help us take a more methodical approach to a demand response. But, there is an opportunity, there is a huge opportunity to still bridge the gap there. Next slide. So the outcome of the project is a 9-step framework for assessing the potential of a building to participate and benefit from a demand management program that engages in the balance of electricity supply and demand. And the property industry through BBP are seeking that this continues to evolve so that the value and the benefit of engaging in demand response is easy to see and easy to use for everybody. Thank you.
Thanks so much, Janaki. That was fantastic. So I'll invite our panelists to turn their cameras and microphones back on. And we'll kickstart with some of your questions. So feel free to continue to put your questions into the platform and we'll work through them accordingly. Beautiful, we've got everyone back online. So just for the sake of the recording, this is the Flexible Commercial Building session at the National Energy Efficiency Conference in 2020. I'm Liz Fletcher and I'm chairing this panel. So let's start with an easy question. Maybe it's not so easy. And I think all our panelists can probably answer this. What do you think the #1 reason that we haven't been able to unlock the flexibility in our commercial buildings, considering the volume that Steve and Janaki and Søren, you all mentioned that exists there? Janaki, would you like to start?
Sure. I'd like to say that we actually do have flexibility in our building stock. Well-tuned buildings use energy in response to weather, occupancy demand, to keep people comfortable and productive. But I think the issue is that we're not often responding to what's happening on the grid on the other side. And the reason for that is because as property owners, we're not experts. And the price signals, as I mentioned earlier, are not strong enough or not clear enough for us to understand anyway. So I think that's the reason why we're not able to kind of respond or, be proactive or be flexible to those signals when it comes to demand response from the grid.
Amazing. And Stephen, do you want to feed off that? You seemed like that resonated.
I thought that Janaki's presentation was wonderful, and it's a lot of the soft barriers I think that come forth. Perceived complexity I think is key, and let's be clear that we generally treat each building in the commercial building spaces as a prototype building, and so each has got different systems and stuff, and so a lack of standardization and a range of other sort of information barriers that make it difficult to sort of push things through. Particularly, there's the with the old 330-300 rule. Energy is the 3, and rental might be 30, and what's it 300 is staff inside the building. So you got a lot of barriers there to overcome.
Søren, what would you say is the #1 reason that we aren't looking? Let's say flexibility.
I can only speak for Denmark and Europe. We have a very strong grid. We don't really need it at the moment. We have large fossil-fueled power plants who take care of the matching between production and consumption, and especially Denmark, although we have a lot of wind energy, we have really strong interconnectors to Norway, Sweden, and Germany. So at the moment, we don't need it. So that's the main point. But when more and more countries go for renewables, we definitely have to start to utilize it, because as Janaki says it, we have the flexibility. We just need to find out how to control it and then to harvest it.
That framing of harvesting is such an interesting construct in an environment where we're thinking about harvesting the wind and the sun at the same time. I think one of the discussions that seems to come up in these topics is, especially when you talk to commercial and industrial businesses, is why should they go through the process of retrofitting rather than just, for example, installing a battery and or making a capital decision? What's your experience there, Stephen?
Well, I'm not sort of convinced that that there's a hell of a lot of retrofitting to actually be done as far as demand response in commercial buildings. As I said, we do have building management systems that have that sort of capability. You know, in terms of retrofitting, you know, putting in a gateway to actually get information in and out. And there's a sort of a decision, you know, will it be a manual demand response or an automated? And I guess I would say that if we are to overcome and scale this industry, automation is critical there. And so then it's about sort of the software and embedded intelligence. You know, it should be low capex type thing. You don't have to go out and spend loads and loads of money on batteries. It's other issues that you have to deal with.
Janaki, is that your experience? Is part of the Better Building Partnership?
Yeah, from a commercial property perspective, you know, as I said, our mantra, our real kind of slogan is efficient buildings running on renewable energy. So, and that's our strategy for achieving our net zero emissions. So energy efficiency is our first protocol, and the market incentivizes us to do that as well. So we've got measures like Neighbours, you know, which is a highly valued benchmark in the property industry. And then that's kind of embedded along when we're doing, you know, any purchases, acquisitions and sales of our properties as well. So there's a commercial value to it as well. So, you know, where we've got these benchmarks in place, which incentivizes energy efficiency as first kind of protocol through towards our net zero emissions. You know, that's kind of where, that's why the property industry reacts and is focused on that aspect.
And I guess the key is to try and achieve energy efficiency and flexible demand, not one or the other, but both. And you know, there's some good work going on in the United States trying to work out programs and stuff for achieving both.
Yeah,
absolutely.
I was going to ask, is there anything that's being done around, just to continue that conversation, around focusing the energy efficiency investments around peak demand periods or minimum demand periods for that matter?
I'll say that these two go hand in hand, because more or less what you need to decrease the energy demand or make the building more energy efficient, the devices, the sensors, the actuators, the software and so on, well, it's more or less the same as what you need for making it energy flexible. So let's do those two things at the same time. But we need also the energy efficiency, because then we need less renewable energy, and because renewable energy is not free. Well, it's free. The energy is free when you first have the wind turbine, but the wind turbine is quite costly.
Yeah, I'm sure anyone who's thinking about their network costs as well is thinking about how that is attributing as part of their energy bill as well. So we do just quickly have one question on that's come from the audience on networks. And Søren, I'm going to throw this to you, but I know it's a very tricky question. Have you been exposed or seen any work that's been done around the cost benefit of updating transformers to enable dynamic voltage control?
No, I haven't seen work, but I have been told by the utilities in Denmark that it is very costly to go from manual controlled transformers to automatically controlled transformers. But I believe that will come, but not overnight. It will slowly they will be replaced when they have to be renewed. But doing it all at once, that will be too costly.
Yeah, that makes a lot of sense. It's all got to be part of a transition like we're seeing in all parts of the sector.
So
okay.
If I just comment, I mean, not necessarily from a transformer point of view, but from a PV curtailment point of view, obviously South Australian Power Networks recently won an award for some of the work that it's doing around sending signals around and enabling of dynamic export controls.
It's a really interesting conversation, isn't it, about how you manage those pieces versus the market conversation. We're just kind of thinking about this from a construct, and Søren, you touched on this, in that we have the technology, it's all here. A lot of this is about how we're going to get people to actually use that. You mentioned that you've done some work around stakeholder engagement in your research.
Yes, but that was more theoretically, where people were informed about what is energy flexibility, and then they ask would they like to participate. But the problem is, I believe that first of all we need to have a benefit from joining a scheme, and then we also have to increase awareness of why is this necessary? Because in Denmark, people say, well, we have an intelligent power grid, because when I turn on the light, I have light. So what's the problem? So there's a lot of information that is needed, and understanding that what actually will happen if we don't do this. And in California, they have the problem because they have weak power grids. So they have brownouts. So people know that this is a problem. And in more or less the countries in Africa and so on, they know what it is about when the power suddenly is away, because there's a too big load. But in industrial countries, we don't really have the problem. So people do not understand it, and it's very difficult to explain it to them.
Janaki, I know that some of these papers around stakeholder engagement came out of your survey, but just quickly to Søren's point, the instances that we've seen in the Australian market that are such as Søren has described, did that impact any of the thinking?
Yes, absolutely. And this was, I can talk from a more practical perspective in terms of the stakeholder engagement and how do we make, how do we more actively participate? And, that really was one of the key drivers of the project, was to, create awareness of what demand response is, how the commercial property industry can take a more active role, and also to understand the web of complexities that lie there. I think from my point of view, it really is the next step is, to bring all of these pieces of the puzzle in one kind of place. So, we want the energy use profiles, we want the building comfort requirements, we want the grid tariffs, we want the incentives associated with it, almost all onto one dashboard, so that you can see it all very clearly, not in a cluttered way, but, very clearly of what the push and pulls are, and then automate it. So that as a building owner, at the end of the day, we're really kind of interested in ensuring our assets are efficient and operating as optimum as possible, and demand response. In addition to that, is that we also want the security of the infrastructure that's supporting our assets. And if we can participate in making that happen or contribute to that in an active way, then, we would love to do that. We just need, the tools to be able to act and do our part.
Stephen, you are nodding vigorously.
Yes. What Janaki said, but also what she said previously, data is not information, information is not knowledge, knowledge is not wisdom. And it's sort of, we have that sort of phrase that you can't manage what you don't measure, but there's a big gap between managing and measuring. And I think that's where I'm so excited by digitalization as an opportunity. I mean, we think of digitalization as being a tech play, and it's all about hardware and servers and all this sort of stuff. But the next wave of digitalization is all around presenting the information in actionable ways, so that people have got this user interface that enables them to understand what they're doing. So, yeah, very much what Janaki is saying, and I think digitalization is on the cusp of helping us to get that sort of scalable outcome.
As a marketer, you are speaking my language. Yes. So there's a question from one of the participants, Kieran McLean, just kind of building on that. So what role do you see in data standardization and semantic tagging playing in unlocking building data?
Oh, yes. Can you take data out of the building? Can you reuse it many times? And that sort of semantic tagging is all about that sort of overcoming this sort of prototype building type thing. So because a data stream coming out by itself is just, it might be 4 to 20 milliamps or what have you, but it doesn't mean anything until it's got metadata attached to it. And so the ability to sort of standardize around these sort of tagging frameworks, and in the data clearinghouse, we're using the BRIC standard, which is a semantic ontology that enables people to, code once and then apply it across lots of buildings and stuff. So yeah, there's a lot in sort of standardization and data structures and stuff, which again is part of that story of how do we get scalability in this industry and enable businesses to thrive, offering services across a building portfolio rather than just going in every bespoke building one at a time.
Lauren, yeah, go for it.
Data is very important, and what we are working a lot with in Denmark is data-driven modeling, where you don't need that much of data from this one building as such, but you actually try to model what is going on, so you can send out a penalty signal and see what is the response, and then you can teach the model to forecast how you should, which type of penalty signal you should send out to obtain a certain behavior by a lot of buildings. So you don't really need to know the single building.
And so, Søren, what party is going to end up providing that signal? Is it an intermediary? How do you see that playing out?
Say it's an aggregator. Because buildings are normally not, they have flexibility, but not enough actually to do something big for the grid. So you need to aggregate a lot of buildings, the flexibility from a lot of buildings. And then the aggregator is an entity that make the contracting with different kind of buildings and make their models on how they behave in certain situation, and then try to fit that into a flexibility market.
Is that your experience too, Janaki? Yeah, and I think in the study we found that, I mean, even, in my role at Charter Hall, like we would rely 100% on intermediaries to support us when we're looking at, participating in demand response. But I will say that there is, again, going back to the information gap, there is data, but the information gap is so great that as an end user, we're unable to really determine the value we're going to get from participating, which is probably why a lot of property owners, we can do a lot more given our collective footprint and our impact on the grid. But I think that's another great opportunity for the market through intermediaries to really come to us and really unlock that value and making it simple so that we can, and de-risking it to a certain degree, or building our appetite and awareness to it so that we can participate more actively.
I'm sure there's plenty Energy Efficiency Council members who are very happy to hear you say that. It's a really exciting time in Australia. Next year, we'll get a wholesale demand response mechanism. This is an increasing piece that we're going to see as we move through. So just closing out with the last question. So one more question, guys. If you had the ability to influence the world, change whatever you could possibly change, what would be the first thing that you did to unlock flexible building capacity? Stephen, have you got some thoughts there?
Well, obviously, I'm going to come at it from a technology perspective, which is a dangerous place to come from, perhaps. But, obviously, you've got to break this into sort of bite-sized chunks, I think. And, if automation is the way that we're going to get scalability and stuff, you've got to get step one of automation, which is to establish that sort of connectivity, two-way connectivity, so that the electricity market and the property industry can actually talk to each other. So I think, that sort of digitalization, sort of data piece is kind of fundamental there. So, but I would say that, yeah.
So the machine's going to take over.
Well, it's the opportunity to encode each person's business rules such that they can trust each other, is kind of the way I see it. At the moment, if the electricity industry is sitting there talking to the things and they want to say that we're going to switch off your air conditioning, I don't think that's going to happen. And so there's business rules for the electricity industry. They want firmness when they have demand response. And then there's business rules for the property industry, and that's got to be encoded somehow or other. You can't have every single decision being made in the moment where demand flexibility is required. It's got to be coded up in advance and then allowed to automate. Yeah, not quite the machines running the world.
Caveated. Søren, what would you do if you had ultimate power?
Well, two things. First of all, I would think the main point is to make people aware we have a problem that is emerging. So I would plan a series of well-planned brownouts, so people can understand, well, we have a problem now, so please be aware. And then I will, because consumers, it's a slow process. So I will also tend to go for legislation to get some, for instance, the building codes saying that that a building should be energy flexible, and actually they are doing it in California. So it's not something new.
Yeah, they're really interesting things. So Janaki, what's your utmost?
I think I'd lean towards, make it as simple. If I could, as a responsible building owner, we benefit from efficient operations of our asset, as I said, and resilience and reliability of the infrastructure that supports our portfolio is paramount. But having said that, we are not energy experts. Our role is to ensure our assets are operating and our occupants are happy. And so in an ideal world, demand response should be simple, transparent, and automated. So yes, I would be very happy if the machines could do it, albeit it being transparent so that we, are still in control, of course. But I think automation is the way to go, and just demystifying it, making it simple, connecting the dots so that, we can have transparency.
I love that. Simple, transparent, and automated. Yeah, I think I might reuse that. Thank you very much. So now it's about time to wrap up so that you can all take a little bit of a break. So we've got a half-hour break before the next session. But firstly, I'd like to thank the three of you so very much. For Søren for waking up very early and joining us all the way from the other side of the world. Janaki.
Yeah, but I don't have jet lag. That's the good part of it.
There are benefits. So thank you so much, and really appreciate all your insights. So for everyone in the audience, take a break, but don't forget to come back at 5:30 for a sundowner session. Luke Menzel, the CEO of the Energy Efficiency Council, will be having a sundowner session with Sally Sadegel, the one of our MPs. Katie also reminds me that if you do your survey, you can win points towards a very exciting prize at the end. So don't forget to do that as well. I hope you've enjoyed this session and have a lovely night. Thank you so much.